Can poor power distribution cause equipment failures? In recent days, a pressing question has emerged in the electrical engineering community. Can poor power distribution cause equipment failures? As industries and homes increasingly relying on stable electricity, understanding this issue is more important than ever. With recent reports highlighting power outages and equipment malfunctions, many are searching for answers. Let's look at this question from an electrical engineering standpoint. Poor power distribution can absolutely lead to equipment failures, and here's how it happens in real-world situations. First, consider what poor power distribution means. It refers to issues like voltage sags, surges, imbalanced phases, inadequate protection, and faults that are not quickly isolated. These problems can stem from aging infrastructure, lack of maintenance, or insufficient grid upgrades, especially at the edges of the distribution network where faults are more common. When voltage is too low, known as a sag, or too high, known as a surge, electronic and electrical equipment may not operate as designed. Motors can overheat, sensitive electronics can malfunction, and insulation can break down over time. For example, if a conveyor motor is connected to a circuit rated for 25 amperes but draws 30 amperes continuously, the overcurrent protection device, like a circuit breaker, should trip to prevent damage. If protection is missing or fails, the motor and wiring can overheat, leading to failure. Short circuits are another risk. A damaged wire can cause a sudden, massive current flow. Proper fuses or circuit breakers should interrupt this quickly, but if protection is inadequate, the resulting heat can melt insulation, damage components, and even start fires. In residential settings, arc faults from loose connections can also cause fires if not detected and interrupted by devices like arc fault circuit interrupters. On the distribution grid, most faults are temporary, things like tree branches touching a line or animals causing a short. Modern systems use reclosers to automatically restore power after these brief interruptions, but older systems relying on fuses may leave customers without power longer and do not distinguish between temporary and permanent faults. This can mean repeated stress on equipment as power is interrupted and restored, increasing wear and the chance of failure. Grid instability is another factor. As grids incorporate more renewable energy, the lack of rotational inertia from traditional generators can make the system more vulnerable to voltage and frequency swings during disturbances. If the grid cannot maintain stable voltage and frequency, equipment may be exposed to conditions outside their design limits, raising the risk of damage. Poor power distribution, whether from voltage issues, inadequate protection, or grid instability, can directly cause equipment to fail. Proper design, maintenance, and upgrading of distribution systems are necessary to minimize these risks and protect both equipment and end users.